Hello, everybody. My name is Francis Defau, and I'm the marketing manager at Codit. I would like to welcome you to our webinar on Kubernetes event-driven autoscaling. You're all very lucky today because we have two hosts for you. The first one we have is Jeff Hollan. Jeff is the principal PM manager at Microsoft Corporation for Azure Functions. And he will be joined by my colleague, Tom Kerkhove. He's our Azure architect at Codit and also an MVP. Now, if you got any questions during this webinar, don't hesitate to enter them in the Q&A session. And at the end of this webinar, Jeff and Tom will be very happy to answer these. And with that, I leave you in the very good virtual hands of Jeff and Tom.
Great, awesome, thank you. Very excited to be here today to talk to you all a little bit more about KEDA. So the folks on the call here, just a quick intro. So I'm Jeff Hollan. I'm a program manager at Microsoft. So I live here in Seattle. My team helps manage and build Azure Functions, but also KEDA. And also thrilled to have on the webinar with us Tom. Tom Kerkhove works at Codit. He's an Azure architect. He's also one of the main KEDA maintainers. So there's only about 4 folks who maintain KEDA from day to day as it has evolved and been created. And Tom is one of them. So Tom and I have actually had the chance to work quite closely together. So you'll hear from him in just a few moments as he shows you some of the powerful things that folks are doing with KEDA. So with that, and to get started, let's talk a little bit about what we're going to share today in this webinar. So we're going to discuss KEDA, and the framing of KEDA and how we like to often talk about it is around serverless and Kubernetes, how you can bring the benefits and the capabilities of something like an Azure Functions into Kubernetes, how it makes auto-scaling the same way that functions scale very simple with KEDA. We're going to go into the details of how it actually works, what we're working on with the product, and then go into some Q&A for any questions that you might have. I believe there's even a Q&A window if you want to ask questions as we go, and Tom and I will be sure to give time to answer them. So when it comes to serverless in general, there's a few main scenarios that we see folks are interested in serverless for. This idea of event-driven compute, having scale and resources made available on demand. One of the first ones that we see is just around automation. I often think about this as like the gateway to serverless because it starts with something like, hey, we usually run this PowerShell script, or we do this little pull request job or program every night, or whenever someone opens a new code review. Could we just push this to the cloud and have it be fully automated for us? So those types of automation tasks, just doing something you normally might manually kick off, putting a timer on it, making it trigger over HTTP is a very big scenario. Another huge one we see is this kind of glue between services. This is especially where you start to see coordination between things like Azure Logic Apps and Azure Functions, and that you have maybe a NoSQL database over here, you have a SQL database over there. You need them to be able to talk to each other, and so you can just glue in some serverless capabilities in the middle. Hey, whenever something happens in NoSQL, go make sure that you validate it over on the SQL side. We also see this for APIs. If you think about a mobile or a web backend, especially one that you anticipate bursty or low traffic for, serverless can be a really natural fit to give you that on-demand compute and be able to scale to whatever the needs of that API are. And then finally, especially for some of these large implementations of serverless, event stream and queue processing are massive. If you think about an IoT scenario where every single device is sending some data, and for each one of those data points, you want to be able to do some analysis, maybe some transformation, some validation. You can just attach a serverless function or some serverless code to that event stream. And what's nice is it's going to be able to scale as that grows. So you add 1,000 more IoT devices, your application's just ready to handle it. It will dynamically scale and grow to that traffic. So these are some of the big ones to help kind of set the context for what are the types of problems that folks are using with serverless. And an example of that is a customer that I've personally spent a lot of time working with, which is Best Buy, which is an electronics retailer in the United States. They have to be able to scale to billions of events as folks are buying hard drives and operating systems and whatever else people buy at electronic stores. So they wanted to build a system that could serverlessly process all of the orders that are coming in specifically during the holiday season. If you think about a day like Black Friday, they wanted to make sure that this could scale and handle an increase of load as people start grabbing all of the new promotions. So they wanted to make sure that they could connect to event sources, that they could scale on those event sources. They really wanted to optimize for cost and only having compute available on demand. And they had a few requirements about how those events were handled. They needed deep integration with things like Kafka to make sure that all of these orders are processed in order, that everything was handled correctly. So they were able to use Azure Functions to do this. But you can even see it's not uncommon that we see something just like this, where there's a line where, yeah, maybe some processing is happening in the cloud, but I might have some processing that's actually happening either on premises, maybe in another cloud. Maybe if it even is in the cloud, I'm going to choose a tool like Kubernetes. So with that, let's transition from what we've been talking about in a generic sense to how and why you might want to use serverless in Kubernetes. And specifically, this pairing is appealing for a few reasons. So obviously, there's benefit to saying, hey, I'm just going to use the Azure Function Service or Azure App Services or whatever other service that might be and not have to worry about Kubernetes. But sometimes I actually do want to bring that in to my serverless equation. So the big one I called out was something like Best Buy. I might actually have something on premises that I need to run, and I can't run the Azure Function Service as it is today on premises. So I can use Kubernetes to bring that experience on premises. Another scenario I see often is maybe you're already deciding to take a big bet on Kubernetes. You're creating things like a service mesh and microservices in Kubernetes, and you want to have your functions running in the same context as the rest of your application. And so sometimes the question is, well, how do I get my functions to run and scale there too? You might also have custom compute requirements. Think of this like you're doing machine learning and you need GPUs, or you need really high performance compute that maybe is not available in a public cloud service. So here you could use Kubernetes and have flexibility over the types of nodes, whether it's really large, or even the other month we saw someone using KEDA to run compute on Raspberry Pis. And so maybe it's actually you have very small compute that you want to be able to leverage. And then finally, this is a huge one, especially for a lot of enterprises. There's concern around serverless in general of saying, hey, the tech sounds interesting, but I don't want to be locked in. What if I need to make a change? What if there's something about this service that's not working for us? And Kubernetes gives you that vendor neutrality. It's the common denominator of the cloud. So while this sounds appealing and it might have scenarios, maybe you even watching could think of reasons where you want these serverless capabilities in Kubernetes, how does Kubernetes scale today, just out of the box? And if we were to look at something like almost that Best Buy scenario where you have these events coming in with something like Kafka, so you can almost imagine each of these queues, maybe this is a Kafka stream, maybe this is a service bus queue. How Kubernetes is going to work is you have these different nodes or virtual machines. And inside those nodes, you have these pods, which are these collection of containers. So maybe it's just running fine. It's processing messages. You have a few containers that you've published that are processing those messages. Well, is it's happening, you have a few out-of-the-box components that Kubernetes can use to drive scale of these pods, right? If I get a lot more messages into Kafka, what's going to happen? The first one is something called the horizontal pod autoscaler. This is a service provided just by Kubernetes, and its job is to decide, do I need to scale out your services? Do I need to scale out your containers? And by default, it actually is pretty simple. It only looks at things like how much CPU is being used, how much memory is being used, and it uses that to try to guess what to do. But in a service like Azure Functions or AWS Lambda, that scaling is too slow. If we're only looking at CPU, we're reacting way too late in the pipeline. But luckily, Kubernetes does provide this thing called a custom metric provider. And you can actually say, hey, Kubernetes Horizontal Pod Autoscaler, or HPA, I want you to actually look at this metric provider that I'm going to provide that knows how to look at how many messages are in that Kafka topic. And so in this case now, as that queue would grow, that custom metric provider could say, hey, Horizontal Pod Autoscaler, there's actually 1,000 messages here that I need to have processed. So that can help drive the scale, even to the point where if a lot is being scheduled, Kubernetes can even decide to scale the entire cluster. It could add an entirely new virtual machine. So now you actually have more compute available. And all this can be powered today. This is just Kubernetes. There's nothing unique here. We haven't even got to the KEDA stuff. This is how you could do it without KEDA. So it's possible. You can go figure out custom metric providers. You can go hook them up. You can wire them up to get this experience that I just showed here, but it's not quite ideal. And one of the reasons is because as people are building these cloud native applications, they're going to have a number of different external sources, right? You might have some data that you need coming from something like an AWS CloudWatch metrics adapter. You might be using a solution like Prometheus inside of Kubernetes to do monitoring and metrics, which you need to then integrate also with things like Azure Monitor and Azure Metrics. And so piecing all of these things together is possible, but now it can be a little difficult because now, in addition to just building my application, I'm on the hook to make sure that I'm creating and hooking up the right metrics adapter. I might have competing metrics adapter. It gets a little bit complex. So in an effort to bring this serverless-like scale to every single Kubernetes cluster, this is really the origins of KEDA. So KEDA is a Kubernetes event-driven auto-scaling component. It can be deployed into any Kubernetes cluster. It allows you to automatically scale deployments and jobs the same way that something like Azure Functions scales functions in the cloud. It provides that same proactive scaling experience into any cluster. It's vendor agnostic. It has built-in scalers, so it has over a dozen different sources that it knows how to pull metrics from. It has a nice way around security and authentication. So if you're communicating with a service like Azure Service Bus, you actually don't even have to put in something like a connection string. You can use pod identity. You can have managed secrets, all built out of the box and integrated with KEDA. This also gives you the ability to do something that Kubernetes doesn't do out of the box without custom metrics components, is scaling resources all the way down to zero. If that Kafka topic has no events on it, you can actually make it so the containers don't run on any node, so that you're saving that compute, you're saving that CPU for resources that do need it, and KEDA provides that out of the box. This also gives you the ability to take an Azure function that maybe could be running in the Azure Function service. You could take that same function, not change any code, deploy it to any Kubernetes cluster with KEDA. That Azure function is going to be able to run and scale in that Kubernetes cluster the same way that it scales in the cloud. So now you have complete portability and vendor neutrality for Azure Functions as well. Now, initially, it started as a partnership between Microsoft and Red Hat. Very quickly, actually, Codit was involved, and they're now one of the top contributors for KEDA all up. We actually have a large community, which we'll get to later today. And the hope here, too, is that you're able to now just focus on your app. You don't have to be thinking about the scaling internals. You don't have to be worried about how do I hook up all these custom metrics adapter. Tom's going to show you in just a few seconds how you can just write a simple event-driven app, wire it up with KEDA, and you're good to go. So before we get to the demo, the last thing I want to just re-emphasize is KEDA is completely cloud agnostic and vendor neutral. You can run KEDA anywhere. You can run it in AWS. You can run it in Google Cloud. You can run it in Azure, but it also integrates with services from multiple different providers. It integrates with AWS event sources, Azure event sources, Redis, Prometheus, MySQL, RabbitMQ, like everything on this list. It's completely flexible and agnostic and extensible. So you can also start to bring in your own event sources to this rich scaling experience. So with that, I'm going to pass it over to Tom to walk us through a quick demo of seeing KEDA in action.
Thank you very much. So what I'm going to show is one of our samples that we provide, where we will automatically scale a .NET Q worker for Azure Service Bus, but basically it works the same way for all of the scalers that we have in the ecosystem. So if I go to my cluster, so on the left, you see that I have some deployments already. There we go. So I have the KEDA operator and the metrics API server. So that's basically an installment of KEDA. And then I have an order processor and an order deployment. So on the right, you see that web deployment, which is basically just a UI that shows how much messages we have in the order queue. But you also see that we have the processor who basically is waiting to process. And it's important to note that there are 0 instances of that deployment, which is actually already what KEDA does. if there is no message on the queue, it will basically remove all the workload. So that allows you to save basically compute. Now, I will show you how easy it is to basically add autoscaling. And that works by adding a scaled object to your Kubernetes cluster. So when you install when you install KEDA, you will also install our custom resource definitions, which allows you to create a scaled object. And as part of that scaled object, it's very simple. You just say which component you want to scale. So in this case, my deployment is called order processor. I say that it can automatically scale out with a maximum of 10 instances. You can also define a minimum replica count, so that's fully configurable. And then I say you need to check every 5 seconds, and if you can scale down after 5 seconds, start removing nodes. So you also have full control over that. And then I basically define what the scale trigger is that I want to use. In this case, I want to scale based on an Azure Service Bus queue. And that name of the queue is orders. And if there is more than 5 messages on the queue, I'd like to add another instance. The last part is the authentication. So either you can refer to a secret in the scaled object here, but as of KEDA 1.0, we have added the concept of, and I will now scroll up, the trigger authentications. With trigger authentications, you can basically deploy authentication for a certain trigger and reuse that across multiple scaled objects. It allows you to refer to environment variables, secrets, but also pod identities, so that you no longer have to maintain any secrets. Another reason is also that this allows you to decouple the responsibilities, so the developers can deploy the scaled objects and define how it needs to be scaled, but then the IT person or the security person will provide the credentials for KEDA to authenticate with. So we basically give you a separation between those. Now, if I go back to my Kubernetes cluster, you can also do a get scaled object to see what's installed on that cluster. And for now, there is none. So if I do K is an alias for kubectl. And so if I do an apply -f autoscaling, you see that it added my trigger authentication, my scaled object. And if I now want to get all the scaled objects again, you will see that we have that one on the left. So if we now start adding messages to the queue, KEDA knows that it needs to check the order queue. And if there are more than 5 messages, it will scale the pods. So if I do a get pod now, you will not see any order processor pods. So I will now do a watch so that if something changes, you will see the action over there. And on the top at the right, I have a order generator. So I will use that to generate some load. And I will now say, hey, create 100 orders, and it's going to queue them on service bus. Okay, so in the web UI, you already see that the queue starts filling up. And then on the left, you can see that KEDA immediately starts adding instances. And the containers are being created, etc., etc. So we start getting more pods. So if I now do a get deployment, you will see that we have a total of 4 pods already. Now, as the messages start being processed, because the pods are up and running, you'll see that the queue is draining, and over time, it will basically fully shut down. Because I took 100, it might maybe take a small amount of time, but in the meantime, I can show that KEDA was very easily installed with just Helm. So you can just do a Helm install KEDA, and we will basically deploy everything for you, and you don't have to worry about anything. You just have to provide the scaled object and the trigger authentication that I've shown, and for the rest, it's just up and running. And now you see that the pods are already terminating because there's no workload anymore. So basically, we remove them again so that we provide the capacity to the other applications in the cloud. So very simple way to auto scale, and It's really super important to have this, in my opinion, because it's just that simple. It's auto-scaling without having to worry about the details. Okay, if I go back to the slide, how does it actually work? So KEDA does not reinvent the wheel. Like Jeff mentioned, we basically fully build on top of Kubernetes, where we manage the workloads to provide that 0 to 1 scaling, which is not out of the box with Kubernetes. We handle that, but we also register ourselves as a metric adapter. And we feed the metrics to the HPA. So that means that if we see that there is nothing to process, we will get rid of all the pods. So that's the scale to 0. But when we see that there is workload again, we will add an instance and we will trigger the HPA we will deploy an HPA to start the auto scaling based on the metrics we provide. We provide out of the box and add-on scalers. The difference is that 90% of all the scalers are part of the Helm installment, the KEDA installment. But we are also adding add-on scalers that you can separately install in your cluster if you want to have them. For example, you can also scale Azure Durable Functions nowadays, but that is an add-on scaler that you have to install. Now, if you want to get started with KEDA, it's super simple. You can write the Helm chart that I used, or you can also use the operator framework to install it in your cluster. So Jeff showed this before, which was the more complicated landscape, but with KEDA, it becomes a lot more simpler, where we basically just provide you one unified way of getting the metrics and scaling them. And instead of writing your own HPAs, you just write the scaled object on top of your existing deployments. Does that mean that you do not need any HPAs anymore? Definitely not. If you want to do auto scaling on CPU and memory, you can still do that because that works fine. Now that we have KEDA, it also becomes more simpler here. We just replace that and we just auto scale based on the workload. And if there is no load anymore, then basically we get rid of the additional nodes and scale to 0. But if one message comes back, KEDA will just add another pod. Now, just as a summary, so imagine we have a KEDA installment. We have the Kubernetes metrics API and the HPA. What we will do is, if you have an event source, you will have a deployment with the scaled object. You will take that and deploy that in your cluster. But because there's nothing to process, it will be fully idle. And then once the workload is there, we will just start adding more instances. So basically, the KEDA operator is the glue between scaling your deployments and the Kubernetes metrics API. Now, I'd like to hand it back to Jeff.
Perfect. Thank you, Tom. Fantastic demo. I need to get those exact bits and split the screen just like you did. So one of the things we're most proud of with KEDA has been the community reception. So it's already have 1.8 thousand stars on GitHub. We just initially released it a little less than a year ago. But in that time, we have over 50 contributors. This includes some of the largest tech companies in the world, as well as Codit, which is definitely a good company. We have bi-weekly community stand-ups. So every other Thursday, we have, or depending, I guess, on your time zone, we have community stands up if you want to join and participate. Here's the landing page for KEDA as well. And just an example of a few of the customers and clients who have started to use KEDA. There's been a few published use cases as well. In fact, not here is PureFacts, who is using both KEDA and Azure Functions, as well as a bunch of other folks. Astronomer has been a great example of using Apache Tech with KEDA. It's really exciting to see. And I just love, like we just included a tweet here of, you know, whenever we make some noise about KEDA, I always love seeing from the community folks who are like, hey, this looks really exciting. And then we have folks like Richard Hooper who are like, yeah, I've actually been using this in production for a while. It's been great. KEDA is very single purpose. It's not trying to do everything. It's just doing that event-driven scale, and we feel it does it very, very well. So we've been very happy with the response that KEDA has had in the community that has been built around it. So If you think about Kubernetes in general and Microsoft and Kubernetes, KEDA fits right into the rest of this ecosystem. So there's a number of pieces of technology that work great in Kubernetes cluster. There's packaging and distribution technology like Helm and Porter that enables you to take KEDA, take your application, take dependencies, and bundle them all up together. Use something like Helm in the mix, use something like other applications or calls to Azure APIs. There's rich integrations with service meshes and policies, integration with developer tooling. I'm very excited about some of the things that are possible with things like dev spaces or Visual Studio Code extensions or Draft and Brigade. Really around scalability too, KEDA plays a key role, but the virtual kubelet is another piece of technology I'll just plug here. This isn't necessarily about the virtual kubelet, but I feel like they go very well together. The virtual kubelet means, if you think back to the slide Tom was just showing, where you have the different nodes, you have the different pods. If there's a world that KEDA is telling Kubernetes, hey, we actually need more containers, virtual kubelet lets you spin up a serverless container using technology like Azure Container Instances, so that rather than having to deploy an entire node to keep scaling out, you can just start to run serverless containers. In fact, you can use KEDA to say, only ever scale this thing on serverless containers, never take some of the compute from my core nodes. So a lot of incredible tech here that you should be using. Obviously, I mentioned this before, but Azure Functions pairs very well with KEDA too. Now, the reason that you might consider bringing both of these together is if you think about, if I'm connecting to something like Service Bus, you are totally flexible and open, and sometimes you might prefer the way where you're going to write all of the code to manage how to pull and dequeue and deal with messages from Service Bus. If you use Azure Functions, it just gets you started right away, and you say, hey, I want a function that triggers on Service Bus, that triggers on Kafka. You just start writing your code. Like, this is the code I want to write. I want you to do this with the message properties. And the Azure Functions runtime will be in charge of pulling those messages and triggering. And then when you deploy it to Kubernetes and use KEDA, now it's able to scale that function as well. So if you want to write even less code, have a fully serverless experience that could run in Kubernetes, but then could be at any time shifted to run in the Azure Functions service, that's a good pairing that we just want to call out. In terms of roadmap, this has even been updated since the slides. This is rapidly moving. So I mentioned KEDA is fairly young, but that community response has been very strong. KEDA has officially been voted this week to be accepted as a sandbox project in the Cloud Native Compute Foundation. So right now we're in the process of onboarding KEDA to the CNCF. This is a really exciting milestone and some good recognition for the value and benefits that KEDA brings to cloud native platforms. We're also working with the Knative team, who are looking at KEDA, seeing the capabilities that it provides around event-driven scaling, and they're interested in taking a dependency on KEDA to help provide newer capabilities for their platform as well. We're constantly working to add new scalars. In fact, I see some questions that have come in through the webinar. Some of them are on scalars that we do have, some of them are on scalars that we don't yet have. We're working on some new ones. One of the exciting ones that Tom's been spending some effort on is integrating with service meshes so that you have even easier flexibility to scale workloads that might be traveling over HTTP and through a service mesh. And this last question is a great one. What scalars are you expecting? The nice thing about the model right now is scalars, they're fairly simple. When you write a scalar, you just have to write some code that says how many messages are on the queue, should we scale or not. So if there's an event source that we don't have that you want, I'd encourage you to go to the KEDA homepage, the KEDA GitHub repo, and open up an issue so that we as a community can continue to improve and continue to evolve KEDA. So with that, I'm going to pause here. I see some questions in the panelist chat. I don't know if there's other ones. So Tom, I'll let you run with whatever questions you want, and I'm here to help answer as well.
Yes, definitely. So I saw that there was a question about, does it work with server meshes like Linkerd? Like Jeff mentioned, it does not work today yet, but with the SMI spec, so that service mesh interface, we will basically be able to support any service mesh that implements that specification. The reason why we chose to use service mesh interface is that it's basically a specification so that we don't have a lock-in on one certain service mesh, but basically we support that specification instead. There is also a couple of questions about HTTP. So as of today, you can already scale on HTTP-based workloads by using Prometheus. So basically, Prometheus would then have the metrics of the ingress, and then you can scale on that metric itself. Now, we know that it's not very straightforward, and we have a big dependency on Prometheus for that. We're working to improve that. The service mesh interface implementation is one part of that, but we're also working with the Knative folks because they already support that normally. So that's another approach, but over time, I certainly want to get rid of the Prometheus dependency from a KEDA standpoint as well. So yeah, we know it's not ideal today, at least there is something, but it will be improved in the future. Then another question was, do we support SQL Server? No, but I think this one is on the backlog. Is that correct, Jeff?
Yeah, that's right. We just recently, over the last month, we got Postgres and MySQL. SQL Server is the last one left, but we did create an item for it. And actually, those other scalars I mentioned, the thinking is we just copy and paste a lot of that code and then just make the changes needed for Microsoft SQL specifically.
Yeah. Indeed. And then HashiCorp Vault is an interesting one. I have not thought about that one. That certainly makes sense from an authentication perspective, where secrets from Vault could be used. So that's certainly one we'll add to the backlog. And then how does KEDA differentiate between Service Fabric? Actually, it's more of a question, how does Kubernetes is different from Service Fabric? That's a whole other topic. But if I would have to answer that question, I would say that Service Fabric is a high-scale platform which shines at stateful applications. But if I would have to write a stateless application, then I would use Kubernetes because the ecosystem is bigger. But I don't think you can just compare the two container orchestrations like that. I hope that answers the question a bit.
Yeah, the only other thing I'd add in that for whoever's interested, like there definitely is, some of it's just, they're both platforms that orchestrate. And I think, Tom, your point on stateful and stateless is a good guidance. If you are interested in bringing some of those stateful patterns that Service Fabric has, though, into Kubernetes, one thing to look at is another project that recently started up, similar to KEDA in terms of how it's created, but it's called Dapr, D-A-P-R. Which is, it's actually being built by a number of folks who work on Service Fabric as well, to try, in the same way that we built KEDA, like, hey, we can do these things in Azure Functions, how do we do them in Kubernetes? They're saying, hey, these are things we do really well in Service Fabric, how can we bring them to Kubernetes? But Service Fabric's still very valid, very powerful, especially those stateful programming models are great. But yes, there is a larger difference between the underlying tech behind the scenes here.
Okay, anybody else have any other questions? I think we went through all of them, but certainly don't hesitate to ask.
Great, thank you all very much. And hopefully we even see a few of you on the next community call on March 19th for me. But this has been great, and Tom, fantastic presenting with you. So thank you everyone so much for joining.